Welcome to the first major reading of our climate change unit. We will be reading an article called What is Climate and How is it Changing? But to begin, we have a list of vocabulary that I wanted to give to you guys so that you could reference it at any point during the reading. You can always go back to this point in the video to look for these definitions. Very briefly, the vocabulary that is included in the article is atmosphere, carbon sink, carbon source, climate change, fossil fuels, greenhouse effect, greenhouse gas. And so if you're ever curious about any of those vocabulary words while the reading is going on, you can always go back to here. You can pause the video and go back to this section of the video to get those definitions. And so now we'll begin. So what is climate and how is it changing? You've probably seen or heard the term climate change in many places, from magazines to movies, at school and at home. Everyone is talking about it. But what exactly is climate change and how does it relate to our lives? Climate change refers to any change in climate over time, whether caused by natural factors such as volcanic eruptions or human activities. Climate is average weather, including temperature, precipitation, and wind, over a period of time, from months to millions of years. When we examine weather over many years, we can see climate patterns. Earth's greenhouse effect. To study climate change, we need to understand Earth's greenhouse effect. The greenhouse effect is important because it makes conditions on Earth warm enough for many species to survive. Some of the sun's radiation that reaches Earth's surface is absorbed by the Earth, but some of it is reflected back into space by clouds, air particles, snow ice, and deserts. When reflected back, the radiation changes into heat, called infrared radiation. Certain gases in Earth's atmosphere act like a blanket to retain and reflect back down to Earth much of this infrared radiation, making surface temperatures on Earth about 34 degrees or 61 degrees Fahrenheit warmer than they would be otherwise. When the amount of greenhouse gases in the atmosphere rises, temperatures on Earth rise as well, causing a change in climate. Some greenhouse gases occur naturally and some are man-made. Water vapor is a greenhouse gas that occurs naturally as a result of Earth's water cycle. Other greenhouse gases, such as chlorofluorocarbons, CFCs, are created entirely by humans. Many greenhouse gases that occur naturally are also released through human activities. For example, carbon dioxide, nitrous oxide, and methane are all cycled through Earth's atmosphere naturally. Carbon dioxide is released by all living things. You are releasing some right now as you breathe. Nitrous oxide is released by organisms that live in the soil. Methane is released when dead things decay and decompose. Human activities that burn fossil fuels, such as oil or gas, when we drive gasoline-powered cars, for example, increase the amount of greenhouse gases in Earth's atmosphere, affecting the balance of natural cycles. Scientists who study climate change often focus on carbon dioxide because the amount of CO2 in the atmosphere is much greater than any other greenhouse produced by human activities. CO2 accounts for 74% of global greenhouse gas emissions from human activities. CO2 can remain in the atmosphere for up to 200 years. Carbon dioxide levels in the atmosphere have been rising since 1750. Because this increase has happened at the same time as an increase in industrial activities, such as manufacturing, processing, transporting goods, many experts agree that humans are responsible for the increased CO2, primarily due to loss of forests and use of fossil fuels. So we have a quick diagram here of how the greenhouse effect actually works. Some solar radiation passes through our atmosphere. Some is reflected by the Earth and the atmosphere, escapes into space, but much of it essentially reflects off of Earth's surface back into the atmosphere, is absorbed by CO2, is reflected again back to Earth's surface, and then is absorbed. So now we'll move on to carbon sources and sinks. Carbon is one of the two elements that make up carbon dioxide. The other is oxygen. Many processes are carbon sources that add CO2 to the atmosphere by releasing more carbon than they absorb. Carbon sources include burning fossil fuels, coal, petroleum, oil, and natural gas as examples, deforestation, which means the loss of forests, and agricultural processes, such as tilling soil and raising livestock. Many industrial processes, such as making cement, steel, and agricultural fertilizers, are also carbon sources. Certain places, which we call carbon sinks, can retain carbon for a long time, keeping it out of the atmosphere. They tend to absorb more CO2 than they release. Forests, oceans, and soil are the main carbon sinks on Earth. We can change the ability of carbon sinks to hold carbon. For example, when we remove trees from a forest or till soil, the carbon they have been holding is released into the atmosphere as CO2. Fossil fuels can also be considered carbon sinks because CO2 is locked inside them for thousands of years. It is only when we burn them for energy, to heat our homes or drive our cars, that they release this carbon dioxide. So how are we measuring carbon dioxide and these temperature trends? Historic levels of atmospheric carbon dioxide can be measured by studying ice cores. Tiny gas bubbles trapped deep in the ice tell us about gases present in Earth's atmosphere thousands of years ago. One set of ice cores at the Russian Vostok Research Station in East Antarctica has allowed scientists to determine CO2 levels for over 400,000 years. A much shorter and more recent dataset has been obtained in a different manner, by sampling air from atop a volcano. The world's most complete carbon dioxide record has been collected since the 1950s at an observatory near the top of Mauna Loa volcano in the U.S. state of Hawaii. Because this volcano is far from many human activities, a carbon source, and plants, a carbon sink, it is an ideal site for accurately measuring the atmospheric carbon dioxide. Both the Vostok ice cores and the Mauna Loa Observatory show a steep increase in the amount of CO2 in Earth's atmosphere in recent years. The ice cores also show a strong link between CO2 concentrations and temperature change on Earth. The increasing CO2 concentrations have many consequences. 11 years between 1995 and 2006 are among the 12 hottest years recorded since 1850, when global temperatures were first recorded by instruments. Warming air and ocean temperatures have caused snow and ice to melt. Melting snow and ice have led to sea level rise and affected ocean chemistry. Wind and precipitation patterns have changed in many regions during the past century, resulting in an increased rainfall in some places and droughts in others. So very quickly, here is that graph taken from the Vostok station as well as the Mauna Loa. And as you can see, I guess this would be primarily Vostok. If you go back 400,000 years before present, which is now, or close to now, this is a little bit of an older article, you can see how closely related CO2, which is in the blue, predicts temperature change. And so that has been tied directly to increased concentration of CO2, rising temperatures around the globe. So where do we fit in? The exact amount of climate change that is caused by human activities is not clear. However, it is clear that increasing greenhouse gas emissions result in warmer global temperatures, and that human activities produce greenhouse gases. While climate change may not be caused by human activities alone, it is very likely that the changes observed during the last 50 years are not simply the result of natural causes. Is it too late to become part of the solution? No. We already have the knowledge and tools to start making changes. For example, a change in lifestyle, such as using fewer natural resources and reducing travel, can have a positive effect on climate. Even how we eat can make a difference. Eating foods that are grown closer to home can reduce greenhouse gas emissions from transporting food long distances. Schools, organizations, businesses, cities, and governments around the world are taking steps to respond to the challenge of climate change. These groups are all made up of individuals like you. For better or for worse, your actions can have an impact far beyond your own life. You can start making positive changes today to reduce your impact on your climate. And we will, of course, will learn about some of those steps that we can take. Thank you for paying attention, following along with the video. Hopefully you did well on the questions.